Pushing a table. Pushing a table requires energy that is supplied by our muscles. When we apply a magnitude of force greater than the static force that keeps the table at rest position, it starts moving. Human muscles contract while pushing a table that helps them to send an electrical signal to the brain. Thus, a chemical reaction takes place to generate energy to exert force on the table. The magnitude of the force that we apply to push the table is non-conservative as it does not restore completely. Some of the energy is lost due to friction. Lifting a box. The gravitational force pulls all the objects downwards. When we try to lift a heavy box, the gravity makes it difficult. To overcome the force of attraction, one has to apply a magnitude of force much greater than it. The force generated from the muscles initiates the chemical reaction and help in lifting a box. Drawing water from well. To draw water from the well, one makes use of ropes and pulleys. The bucket is tied to the rope, which exerts an external force on it. This leads to the emergence of another external force on the rope known as tension. When we pull the rope, the tension force transmits through the rope to the bucket to lift it. The human body and bucket do not come in direct contact. However, the rope acts as a medium and transmits the force. Swimming in pool. A swimmer experiences 4 types of forces while swimming. The buoyant force acts upwards and helps the body to float in the water. Along with that, the weight of the body drags it downwards. Apart from these, when a person swims in water, the fluid friction tries to oppose the motion. In order to swim, a person has to move their body forwards by applying a great magnitude of force. This is done by moving the hand in optimal motion and path. Playing cricket. All the big and small happening in this universe is related to physics. In cricket, when the bowler throws the cricket ball, it moves through the air and experiences air resistance force. It comes with great speed and force. The batsmen need to apply a huge magnitude of force to hit the ball. Even when the bat and ball come into contact, they undergo collision. That is why sometimes the ball gets deformed, or the bat gets broken. The whole concept of cricket is based on the magnitude of force. Riding bicycle. Riding a bicycle is a simple example of the magnitude of force. It is a simple machine that converts the energy supplied by a person into kinetic energy. The force delivered on the pedal leads to the formation of energy. Work is done to change this energy into kinetic energy and move the bicycle forward. Of course, when the bike comes into motion, a friction force starts emerging. It is only because of this friction force that the tires get damaged after several uses. Also, the bikers find that starting a bike is much more difficult than maintaining speed. This can easily be explained by the first law of Newton's motion, that due to the bike's inertia, it intends to stay at the same position. Squeezing a lemon. To squeeze the juice out of the lemon, a force must be applied to it. This applied force is of type push, as the person has to push the lemon inwards between their fingers to extract its juice. This is a general example of muscular force. Due to the impact of force, the shape of the lemon gets deformed. Applying brake to the vehicle. Applying brake to moving vehicle needs sufficient magnitude of force. When we push the brake inwards with the help of our feet, we apply force, due to which the parts in motion experience friction force. Thus, the kinetic gets converted into thermal energy, and the vehicle stops. So the muscular force applied with our feet generates friction, and leads to the conversion of energies. Towing a car. It is seen that a lighter car can tow a heavier truck. It is possible due to the tension force. Both the vehicles are attached to a tow bar that transmits the force and accelerates the vehicle. It also helps in pulling the truck forward, but at the same time pulls the car backward to some extent and reduces the net force. The tension should be balanced on the tow bar. In order to achieve it, the vehicles move at a steady speed. When the car is applied, the tension pushes the truck backwards and the car forward. Hence the distance between the vehicles increases. Book kept on a table. We know that the Earth's gravity acts on each and every object to push it downwards. Similarly, when the book is kept on a table, the gravitational force pulls it downwards. But as we see that, it does not fall on the ground. This means that some other force must be acting on the book to hold it in the position. This force that keeps the book stable is a normal force. It balances out the gravitational force and keeps the book from falling off. The normal force acts perpendicularly to the surface. Its magnitude is equal to the weight of the body. Walking. The concept of walking is based on Newton's third law of motion. When we walk, we exert muscular force on the floor. In return, the floor generates opposing force on our feet of equal magnitude. This opposing force is friction that pushes us forward and helps in walking. The object comes into motion only when an external force is applied. This means that if we do not apply force, then we won't be able to walk. A ball falling down. A ball that is thrown upwards always comes down after reaching some height. Why does it happen? Why does it not stay or go further up? The answer to all these questions is the gravitational force. All the objects on the Earth experience the force of gravity that pulls them downwards. Hence, we throw a ball upwards, it falls back downwards as the force is pulling it. Airplane flying in the sky. The airplane flying in the sky experiences the air resistance force. The external force exerted on the body flying or moving through the air is known as air resistance force or air drag. It acts in the opposing direction of the motion of the object. The resistance is also caused due to the collision of air molecules and the object's surface. Hence, this force depends on two factors, the velocity of the moving body and the area of the object. That is why airplanes have a streamlined front to reduce the area, which leads to less air resistance force, and hence their easy movement. Drinking juice with a straw. Drinking with a straw needs a magnitude of the force of great extent. Low pressure is created in our mouth, and when we exert force, the juice from higher pressure moves towards the lower pressure. Hence the muscles of the mouth exert muscular force to help drink juice with a straw. Opening a door. Opening a door is a mechanism of three forces: applied force, frictional force, and gravitational force. When we apply force on the knob of a door, the torque comes into action and helps in rotating the door. Torque, the moment of force, rotates the object. The magnitude of the force and the perpendicular distance between the point of action and rotation are the determining factors of torque. Because of this, the knob of the door is placed at the maximum distance from the axis of rotation. The force of friction also acts, but only to a small extent. Hence it does not contribute much to the magnitude of the force. The applied force is transmitted from the knob and helps in the easy rotation of the door. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.